Good afternoon, everybody. So welcome back from the spring break, and we have about 9 days break, right? Let me see our schedule. So according to our schedule, we are almost at the end of our course content. Just we have two major topics: parallel processing and binary search tree. For your final, you will get one question from each. Okay, maybe 10 plus 10, 20 points. Okay, and by the way, I have extended lab 6 and assignment 6, actually assignment 6, either 6A or 6B, until tomorrow midnight. If still any of you did not submit your assignment 6A or 6B on Gradescope, then you can submit it by tonight or tomorrow midnight. That is the last chance. And if you still have an issue with lab, then contact your lab instructor. The labs are submitted on D12, right? So the individual instructor will give you an extension if needed. Yes. Test 3 is graded. I have completed my part. There is another instructor, he is being graded. I don't know, maybe he was out of. So maybe it will be graded by tomorrow or maximum 2-3 days. Almost done. I saw that it is 80% done. But as I discussed in the test 3, because I also disclosed almost all of the questions, right? But the stack operation, push and pop operation. Okay? So I want to let us do a quick demo about push operation and post operation. Can I have some books? Anyone can give me some books or phone? Can I hold this phone? So okay, so I'm making a stack of cell phone, okay? Stack of a cell phone. So this is my push operation. This is this cell is my stack. I want to make a stack. Okay, this is my platform. On this platform, I want to make a push operation. Push means I will insert my phone node as a node on this stack, right? So what will happen? Initially it is empty. If it is empty, I need to check whether it is empty, right? Then I need to check if it is empty, then whatever I will put, that will be my topic. Okay, one thing that we need to know that for every stack, for every node in a stack knows who is the top element, right? Anyone has any sticker? Okay, I got. So every node in a stack knows who is the top. So then this is my, for instance, this is my top. Top element, okay? So that once when I have nothing in my stack, at that time my top was null, right? So then when I put this, then this is my top. Okay, so the stack operation is like that. When the second element comes, it will put on the top, right? Can anyone please volunteer with me that put your phone? You have put your phone on top of this. Okay, see everybody please look at it. What is this done? Top version is done, not done yet, right? What else we have to do? Yes, we have to move the level of this top, right? So this is not, this was the top, but when we took another insertion or push, then top will be changed, right? So move the top. Okay, top will be top dot next. So initially there was top and this is next, and top will be top dot next, right? Okay, so if someone is again coming, can you do it? Okay, she needs, can you come this side so that everybody can see you? She needs to do two things. Okay, first she will insert and then she will do change the top, right? So unless changing the top, operation is not completed. So some of you forgot to change the top. Okay, see title says top or heading, whatever I like, right? But the two things that remember that we need to change the top. So every time a new node or item comes on this text, this top will be changing, right? It will be going from up to up to up, right? Okay, so then how is the pop operation? Good. Okay, so two things. We need to, if it is empty, then return. Right? On something that we need to check empty situation. If it is empty, then there is nothing, right? Return. But if it is not empty, then what do we need to do? Two things, right? We need to take this and as well as what do? Leave phone, right? So will you check the phone as well as top? No. You will check only your phone item, but you have to replace this top to the next step. Right? So can you please do this one? Okay, if you take a item, this is the pop. Two things, right? We will need to take item and as well as change the top. So in my class, I declare this node as a top, the field node top, but in the test I use this as head. But still some of you, I don't say you, okay, some of my students, I did not expect that, still use top. That means they memorize. Because there is no top in my code, right? There are head. Okay, still if you need to do like this kind of demo, do yourself or we can do together. But the one thing that you need to understand this clearly, this although something is one or two lines of code, but I like you to play with this code, make some changes. Intentionally delete one of line, do not delete or also comment out. You can comment out on my visible line and then try to run your program to see the importance of that statement. Then you will realize that this is an important line, so I cannot skip it. Okay, for linked list, stack and queue, still you will get similar kind of problem in your final exam. Okay, and let us look for the final exam schedule. So your final exam schedule is up, and for my section, your section is 3, right? 3 or 2? 2. Okay, so 2, then test will be 1 May 3rd, 1 p.m. to 3 p.m. There is no makeup test for final. Remember that? There is no makeup for final until something emergency, really emergency, because this should go to the register office. Okay, we did not make this schedule. This schedule is made centrally, so I don't have any access to give extension or to change it. Okay, everybody understands this, I believe. Yeah, please let us know ahead of time if you have an emergency or any issue that if you cannot attend on that time. Okay, so let us start. Can you please move? That's in the sheet. In this way. Okay. Okay, so we will discuss parallel programming. Today we will start parallel programming. This is although this is a complicated topic, but we will discuss only the foundation, only the basic. We will not go in depth. So if you are you take any advanced level course like parallel processing or parallel computing in your higher study, or your graduate or undergraduate study, maybe graduate study or undergraduate study, then you will learn more about parallel processing. So when we discuss thread and multi-threading, right, we discuss that there is a concept of running multiple threads or multiple processes simultaneously, parallelly. So think about that. Nowadays we have multiple processors in each of our like computer or desktop or laptop or even in our phone, mobile phones. We have multiple processors. This is sometimes you will see if you see configuration of a computer, you will see that they say core processor or co-processor or something, dual processor. Sometimes say if there is a dual processor, then that means there will be at least two processors. There will be two processors, right? So sometimes it is useful to do some complex operation. For instance, matrix operation, like matrix multiplication. A matrix multiplication is the one of the complex operation that each element is computed by multiplying row elements by the corresponding column elements, right? It needs to sanity check whether the column of the first matrix is equal to the row of the second matrix. Otherwise, the matrix multiplication will not happen. So that kind of operation is a complicated one that takes some time. Another thing that everybody is familiar with, decimal number addition or subtraction or multiplication. For instance, if I have a decimal number 1.7.56, okay, and then I want to add another decimal number with this decimal number, okay, that decimal number is, for instance, 2.75, very simple. Okay, then if I write my 2.75 is like this way, 2.75, and then if I want to add it up or if I want to multiply it, it will not work, right? So because one of the first requirement is that we need to align the points, decimal points, right? So that means we need to add one more digit over here on the right side, and then we need to move all of the digits on side left. Then we can check the parallel position of these decimal points, and then we can do multiplication, addition or subtraction, right? So here you see that although we know, we are very familiar with this from our kindergarten, but there are many tasks. moving or shifting the numbers by multiplying by 10 is means that shifting the numbers one digit left. You have to shift all of the digits from right to left, all digits, one by one. That takes some time. And then after that, you have to check whether you have parallel position of your decimal points. Then you can do the decimal addition or subtraction or multiplication. And after the operation, you need to again put the decimal point. That takes some time, right? To figure out what the decimal point will be placed. So this kind of operation takes time. So if you have an application or a program that has a lot of decimal calculation that will take some time. So then in that case, if you have only single processor, then your computer or program performance will be down. So by considering this kind of situation, in modern computers have multiple processors. For instance, maybe there will be one processor dedicated only for doing like this kind of decimal operations. So that when the decimal operations and a decimal operation comes in, then that dedicated processor will take the control and will do the processing fast. So that kind of concept is called parallel processing. So in order to do parallel processing, in most of the modern computers have multiple processors built in. So still about 80 years ago, 60 years ago. 60 years ago, there was this is a electrical engineer, actually electrical engineer, maybe he was electronics engineer. Okay, his name was Jordan Moore. So Jordan Moore about 1960s, mid 1960s, 55 or 56. Or 64 or 65 on that time. So he gave a theory that he predicted something there. He said within 2 or some people say 5 years, after 2 years, the circuit size will be double with low cost. Just he predicted. And also Moore predicted that trend would continue 1970s or until 1970s or 80s. But still after 50 or 60 years, Moore's prediction is still going on. You see that a few years ago that you would see that even a flash drive or a computer memory or hard drive or a phone memory size are like 2 gigabytes, then came up within a year or 2 years 4 gigabyte, and then again coming 8 gigabyte, and then now coming 16, 32, 64, 128, now 1 terabyte, right? 2 terabytes, but the size is increasing, but the price is still almost pretty same, right? So that was kind of prediction that Gordon Moore made about 60 years ago. But still, there is he is recognized for these predictions because this is a good prediction that many hardware engineers they work with this prediction theory. So parallel computing processing or parallel computing have some advantages. Actually, we already realize those advantages when we We use our computer. Almost everyone do multiple tasks. Sometimes we browse websites, parallelly we listen music, or sometimes we work on editor or something, like we do programming or something. And if you have if you have multiple processors in your computer, I think most of you do have, most of your computers have parallel processors, and thus the operating system is uh, parallel processed. So if your operating system allows parallel processing, then definitely you will realize that your computer is working fast. And but think about that, even 20 years ago, not 20 years, even 10, 12 years ago, the application size was small also, and the computers were most costly, but speed were low. But now, okay, computers cost are pretty same, but or sometimes less than previous, and but computers are faster and memory size high, right? So these are the advantages of parallel computing and parallel processing. So another thing is that not all programs are parallel programs. So far we discussed the programs previously until last week. If a week ago we discussed only single thread programs, but in our last few classes we discussed multi-threaded programs, right? Okay, so a parallel processing is a kind of multi-threading. Okay, so it is an advanced level of multi-threading programming that we will go through this. We will see some sample programs, and even when the applications, even online or standalone applications we use, not all applications are uh, parallel processing of applications, because many applications use the legacy software, legacy version means that version was about 20 years ago, still they are using 20 years ago the software they have, the base software. So still software developers and software engineers are working to develop like new models. It's called when you take a software engineering advanced level class, you will see that there is called framework, or is model or structure or pattern. That is actually, that has name is called design patterns. So then when you take some software engineering class that's called design patterns, so then you will realize that for applications, although inside of the application, frame of application is not visible, but skilled software engineers, they understand, they realize, okay, that this software is based on this kind of structure. So as a human being, so we understand that this is a very large room, right? That nice large hall room, but there are some pillars that hold the weight and structure of this building, right? Although those pillars are not visible, okay, but we do realize that, right? Similarly, skilled software engineer, they realize the design patterns. One of the example is that when we walk roadside or in our community, we realize that when we see a building, most of the time we realize that whether it is a house, or it is a shop or store, or it is an office. Because a house has a different pattern than a store, right? And a store has a different pattern than an office, right? So even without going to without entering in a building, we can gauge that whether this is an office building or a store or a general store or a private house. We most of the time we guess, right? We can guess correctly. Similarly, when you take design pattern, when you understand design patterns, then by looking or realizing some software, but visualizing some softwares and spending some time with it, you will realize the pattern of its design, internal design structure. But not soon. That will take some time for you to take advanced level classes. So if a software has a good pattern, good design pattern, that is then this will be efficient and that will be working good. For instance, if this building did not have a good pattern, for instance, the entry door, if it would have only one door, think about the situation. For an emergency, people would need to take only one door, and that might cause a problem, right? Or even if the door was in the back, then people need to go all the way back and to come in the front. That would not be a good design, right? So similarly, when you understand the internal structure of a program, then you will realize that whether its design is good or not good or pretty good. You will understand this. So actually, modern softwares are built with nice design and then with the effect of having multi-threading and parallel processing concepts. Okay, so the official slides, well, only these 5 pages, 5 slides. That, let me see what was included. I also included, I sent my personal slides to be included on this site. Let me see if that is added, then I can go through. Okay, parallel processing, first one. Which one is first one? Okay, this one I just discussed. And I should have another one, parallel processing part 2. Okay, this one is my personal slide. I send it to Dean Office to upload it. It's good. Okay. This one. This one is the second slide. Let us start today this discussion. In our next class, then we will maybe continue this. But meanwhile, okay, I'm telling you that we are almost done in our course content. Okay, so please, everybody, please start reviewing the content, and whatever questions you have, any problem you have, if you do not understand anything, bring that up and let us discuss. We will discuss those. Either we can discuss in group, or we can discuss with activity, or we can review our entire course content. Okay. Although, because I don't like to spend enough time by spending this, teaching this, because this will really take some advanced level programming experience. Although many of you may not have that level of programming experience until now, so I don't like to enforce you to learn this, because okay, but I want to give you some basic idea that how parallel programming is done. Okay, so in Java, that is called, if there is a fork join tool pool. Fork join pool is the latest and recent technology of implementing parallel processing. It is called fork join pool, all in one word together. This is a technique, this is a tool or technique or software of implementing parallel processing. But this is not the only one. Previously, this maybe fork join pool is implemented in Java a few years ago, 2-3 years ago. But before that, there was other kinds of parallel processing tools that were integrated with Java. So it would be good. So when you learn, you take advanced level parallel processing class. If you take, then you will start from the beginning, and maybe this will be an ending point or something middle. So the concept of parallel programming is like this. You will have multiple processors, okay, and you will have multiple tasks. A task can be a small functions or method, or it can be a module with multiple methods or multiple tasks, multiple methods, or it can be an individual program or application. Okay, so the concept is that, for instance, you have CPUs, the processors, central processing units, like you have 4 central processing units, CPU 1, 2, 3, and 4, and you have 4 processes, okay? Process 1, process 2, process 3, and process 4, okay? And then, so in parallel processing, you will send that, for instance, all processors will be working parallelly. For instance, each processor will take a process, and as soon as it completes, then it will take another process, if any. And likely the concept is that it will be faster. But think about the situation if we did not have parallel processors, multiple processors, right? If we had only one processor, only CPU, and if we have multiple like these 4 processes task, then this process there will be queue of processes. That when the first process is done, the second process will start. Right? At the while second process is running, if needed, then it may call the first process again or call the second or third process. But there will be only one CPU, so the system will be slower. Okay. So the concept of different concept of parallel processing is that, like previous concept, one of the processor concept of parallel processing is called thread pool. So we are familiar with threading, right? In our previous lectures, we discussed thread and multi-threading, how to create a thread and how to start a thread. So one of the traditional way of parallel processing was, and also is available, it is called thread pool. So a thread pool is a collection of worker threads that efficiently execute asynchronous callable on behalf of the application. Asynchronous means not synchronous, not at the same time. There will be a repository, or pool means repository, or stack of tasks. All the tasks will go to that pool, and the multiple threads will take each of the tasks and will execute. So even that was a good technique to do to parallel processing, but later Java introduced another technique that is called executor. Java actually, this is an executor service. It is a kind of is a class. Java included this. So that became another advanced level in parallel processing. So the concept of executor service is that still it is available. Still it is, we can program like this way. So in the executor service there will be a thread pool, okay, and from the thread pool there will be a queues, task queues. Task will be coming from thread pool to the queue one by one, and task will be submitted to the task submitter, and from here the task will the task submitter will pick the task from the queue one by one. So that this second process was better than the first one. I'm not going through live program for actual program for this, but if you are interested in, or when you need, then you can do Google search, like Java programs with executor service. If you do Google search like Java parallel program with executor service, Java parallel program with thread pool, C# program with thread pool, and C# parallel program. So this kind of, if you do Google search, there are a lot of programs available. Okay, but we are discussing just the general concept. So these two parallel processing techniques were older and an older fashion, and recently Java introduced is called fork join pool. This technique Java introduced a few years ago. This is the latest technology of parallel processing, and people believe that this is better and faster than the previous two models. I mean, previous two means thread pool and executor service, this model. Compared to these two, this third technique is fork join pool. I just want to give you some idea of parallel processing using this fork join pool technology. The concept of a fork join pool is that if you have a large task, okay, one thing is that if your task is complicated and large enough, then it is feasible to use multiple processors. Otherwise it is not feasible. Okay, for instance, if you want to carry a large table, then you can take 2 or 3 people, 4 people, right, to carry. But if you want to carry only a single pen, this pen, it will not be efficient that 5 people try together to move this pen from one place to another place, right? That will be inefficient. So in real life, so similarly, if your task is not heavy enough or large enough, then using parallel processing is not a good way, right? So we are considering that my task is heavy enough, and then we can make it sub-task. Okay. The concept of fork join pool, let me make it larger. Okay. The concept of fork join pull is that you will have a task, okay, and you will split or fork the task into multiple subtasks. Okay, then task 1 and subtask 1, subtask 2. And then again you will fork. You will make subtask. Okay, this one, this one, this one, this one, this one. Okay, and when these subtasks will be easy enough or small enough to be executed by a processor quickly, then each of these subtasks will be sent to a processor, and when we get the result, for instance, this result is from this task and this result is this task, and then you will sum or add up or join these results. Similarly, you will join the result of this task and this task into another. You will join this and you will get a larger result, and then you will join all of your sub results to get the final result. This is the pretty understandable concept, right? Is doable. So this is the programming structure of a fork join pull. So now remember that this structure has a similarity with a programming concept that we already know. Can you please guess what is the programming structure? Recursion, right? Recursion is kind of like this, right? In order to find the factorial of 5, we first calculate factorial of 4, then multiply 5 by factorial 4, right? Then in order to calculate factorial of 4, we calculate 4 times factorial 3, then 3 times factorial 2, then 2 times factorial 1, until we go to the base. When we go to the base, then we quickly come back. So since this process has the process, it is called divide and conquer. That means divide and get, join fashion. So the programming algorithm, actually this is a pseudocode or algorithm, is like very simple like this. If you have a task T and then split T into smaller tasks, and for each of these tasks solve T1. T1 means T, first task, second task, and third task. Okay, then when all of the tasks are completed, then join all individual results, and then you will get your final result, then return the final result. Okay, so this maybe I can expand this one. So again, if you have a task, the task should be large enough, okay, and that should be splittable. So split the task into smaller subtasks, and solve each of the subtasks. And when all of the subtasks are completed, that means wait until all of the tasks to complete, then join all of the individual results. That joining can be multiplication fashion, that we use factorial 5 equal to 5 times factorial 4, or it can be addition or any other fashion or joining. Okay, so this is another like stuff, is same thing. So that means if you have two things, two conditions. If your task is large enough and it is splittable, and if you have multiple processors. So we are believing that we have our processor, we have multiple processors, or our processor is able to handle multiple tasks parallelly or concurrently. Then we can use first join pull, and I have my program. In our next class I will discuss this program, and I can show you that this is a simple program. This line of this program. This program is to compute Fibonacci Fibonacci number. Like what is the number of in the Fibonacci series, right? Like what is the 5th Fibonacci number, what is the 10th Fibonacci number, what is the 12th Fibonacci number, or what is the 10th Fibonacci number. So okay, so in this program I had shown that the difference in result, that in different run it will take different amount of time. You may see that, you will see that for the first run it took 7 milliseconds, in another run it took okay, for first run it took 16 milliseconds, for another run it took 7 milliseconds, and it took 5 milliseconds, and it took 8 milliseconds. When you discuss this, then you will understand why there is a variation in the running time. Okay, again I'm asking, this is just I will explain this just to give you a heads up how parallel processing is done, but this program will not be tested in your final. Okay, if you have curiosity to understand this, to know this, then I will discuss this. Okay, but this will not. So I don't like you memorize my code. Although all of my codes are online, you can get it, and I like you to play with this, but do not memorize, please. We will discuss this program in our next class. Okay, thank you. Anyone has any question? Thank you so much. So everybody signed on the attendance sheet.